This is just a brief module on forecasting lab number 2. In this particular lab, we want to figure out how to move cold fronts, warm fronts, low pressure systems, and high pressure systems. What you see currently is map 1, and what we'll do is we will look at forecasting question number 1. In other words, how far will fronts, low pressures, high pressure systems move during the next 24-hour forecast period. And we would click on map number 1 here, or on this link here, and if we do that, we would pull up a surface map. And on this surface map you see a low pressure, a cold front, a little bit of a warm front up there in the east. There's even a hurricane out here in the Atlantic. We have a high pressure, another low pressure, and then a low pressure center up in Canada with an occluded front, which we'll talk a little bit about later in the semester, along with a cold front. So you can see there are quite a few things on the weather map today. You'll also notice quite a few isobars. These are the lines of constant pressure. The more lines you see, the stronger the winds are. So we would expect weak winds down here in the south, Texas, Louisiana, Arkansas, Oklahoma, and stronger winds up in our neck of the woods. Okay, so the first thing I'm going to do for this lab is I'm going to draw each of these features on my lab. So I'm going to draw the low pressure center. I'll go back here and I'll draw my low pressure center along with my front, my cold front, along with my warm front. And again, I'll go back to the surface map to make sure I've got it in the same area. It looks like I'm pretty close there. I'm also going to draw the hurricane, because that's a feature. We won't move that, but I'll just go ahead and draw it on here. It's kind of interesting. A little hurricane out here in the Atlantic. And I'm going to go back to my surface map and see what else I need to draw. I've got a high pressure system, and it looks like it is over, that would be Colorado, southwestern Colorado. So I'm going to go ahead and draw this up on my map 1. High pressure here. And then I'm going to go back to my surface map, and I see I have a low pressure over Southern California, so I'll go ahead and draw that on here. Now there was another feature, a cold front going through North Dakota and into Wyoming, so I'll go ahead and draw that. I had a low pressure system up here. I'm going to go back to my surface map and see if there's anything else. No, that's about it. So on map number 1, which is this map here, I'm going to move the low pressure, the cold front, the warm front, this low pressure over Canada, and cold front back over North Dakota and into Wyoming, the high pressure over southwestern Colorado, and the low pressure over Southern California. I'm going to move all these features for 24 hours. Now, how do I figure out how fast these systems move? Well, one thing is I need to figure out direction. Now, notice the little triangles for the cold front indicates that this front is moving to the southeast. The semicircles on the warm front indicate that this system is moving to the north. I look back here and see the cold front over North Dakota and Wyoming, and I see the triangles pointing to the east-southeast, so it's probably moving somewhere in this direction. But how fast and in what direction will these systems move over the next 24 hours? Well, to figure that out, we go up in the atmosphere up to about 3.3 miles to a surface called the 500 millibar map. Now, how do we actually access this 500 millibar map? You would click on this link here, And so if I click on this link, I will have this map. Now this, you see down here, the 500 millibar map down at the bottom of the screen, and it's for today, and the time is at 7 a.m. our time period here. Now there are a lot of things going on in this map. You see a lot of station models. Remember we talked, that was homework assignment number 1. We have station models all the way up through the atmosphere. And for instance, at this particular station here, we see a 20-knot wind out of the west-northwest, more westerly than northwest. Now over Iowa, we see northwest winds at 500 millibars, 20 miles an hour, 20 miles an hour. And you also notice these solid black lines. These are what we call the isohyps. These are the constant height surfaces where the 500 millibar surface lies at. We won't worry about that for this course. That's an advanced course. But you need to know these solid black lines at 500 millibars are what we call the isohyps pattern. And you can think of these isohyps as a freeway. In other words, this is a lane, this is a lane, and so if you were in a car, let's see if I can change the color of this and make it one where you can see it a little more easily. I'll try black here. So it's if we got in a car and we were moving along these lanes here. Notice I'm staying parallel to these solid black lines. Now we'll figure out why that's important here in just a moment. But let's go back to our forecasting lab. And on map number 2, we have to draw in the height contours at 500 millibars. These are the isohyps, the solid black lines that I was talking about. So let's move on down to map number 2. And I'm going to draw the isohyps pattern at 500 millibars. And I see that out in the Pacific, I have what we call a trough, and then where the lines begin to bow upward, we call these ridges. So I'm going to replicate it here on map number 2. And again, I just have to have a rough drawing of it. Constantly going back and forth between the two maps just to make sure I get this correctly drawn. Notice I'm just drawing in some lines here. I'll look back at my 500 millibar map and see how here's one that goes right through central Iowa. So I'll try to replicate that one. And follow that line. Goes down into Georgia and then back up the East Coast. So you begin to see I'm drawing the isohyps pattern. The one to our north that goes through Minnesota dips down into, it looks like Virginia, and then back up the East Coast. I'll draw this one. And it's like we've got a little dip here just north of North Dakota. Try to draw that little dip in here. I have to go back and erase this line because this isn't quite right. Draw that back in. So you see what I'm doing. I'm just going through and looking at the patterns. Takes a little work. Another one here, like that. And right now I'm just getting a rough overall view of the isohyps pattern. So that should give me an idea. Now, why am I even bothering to draw these? Because what I'm going to do on this map 2 here, so it says on map number 2 above, drawing all surface high pressure, low pressure, and frontal systems and the 500 millibar wind barbs. So I'm going to go back up to my map number 1, take all the features on map number 1, and place them on map number 2. And since I used red for the isohips pattern, I'm going to change to a different color. And I'll go ahead and just make this purple. That'll stand out as a contrast. So I'm going to draw this system here. On map number 2. So remember I had that low pressure system and cold front and warm front. I also had a cold front back over the Dakotas, I believe. Let me go back up here. And I do. And I'll draw that low pressure system with cold front. Recall that I also had a low pressure system over Southern California and a high pressure system over southwestern Colorado. Let me see if I've left anything out. I've accounted for everything. So now, interesting, on map number 2, I have the 500 millibar isohips pattern shown in red here. I've also drawn in surface features such as the high pressure, the low pressure over California, the low pressure with cold front over the Dakotas, the low pressure out east, just along the Great Lakes, cold front and warm front just north of Maine. So now that I have both the surface and the 500 millibar mat drawn, I need to also put the 500 millibar wind barbs on map number 2. Now I'm not going to place all the 500 millibar wind barbs or station models on this map. Just the winds at 500 near these features that I want to move, such as this front along the eastern seaboard, this front in the Midwest, the high pressure over Colorado and low pressure over California. Now notice that these fronts are going to move parallel to these isohips. So what will end up happening, this low pressure will continue to move off to the northeast along or parallel to this isohips pattern. It's just like if I got in a car here in North Carolina and I moved parallel to the isohips pattern. That's the direction. Now we have to figure out the speed of these fronts, and we get that speed by looking at the 500 millibar winds. So let me go and pick off some 500 millibar winds over the east here. Right here I'm going to pick out an average. I've got 45 here, 25 here, near the front, so 45 and 25 is 70. Take the average, divide by 2. The average winds at 500 millibars is about 35 miles per hour. Now these are the winds at 500 millibars. So let me go back to that. And winds along here, the average wind speed is about 35. So I'm going to put in 35 here. And so I need to look at the average wind speed at 500 millibars near this surface front. I'll go back. And this is the area where I'm looking for average wind speeds. I have a 50, a 35, a 55, so I'm going to do 55 plus 50 is 105 plus 35 is 140. Take 140 divided by 3. And that is roughly, well, let's do the math over here. 40 divided by 3. About 46 miles an hour. We'll just round it off to 45. So I go back here. and I say my average wind speed here is about 45. So I'll do a wind barb of 45. And notice, so this front, or the winds at 500 millibars, about 45. Now we know this front will follow somewhere along this path. We just have to figure out the speed. And you would do the same thing for the high pressures and the low pressures. Well, let's look at our formula. Distance traveled. Wind speed at 500 near the surface, low and high pressure systems. Well, for this particular front, over in the east, we had an average wind speed of 35 miles per hour. So I'll put 35 miles per hour times the number of hours forecasting into the future. As I'm making this recording, it's right around noon on Sunday. I'm forecasting 24 hours. If I was doing 24 hours, I'll just go ahead and put the number of hours forecasting in the future. 24 hours times this 0.5. Now this 0.5, the reason we're taking half here is because the wind speed's at 500 millibars. We don't want the actual wind speed at 500. We want the winds at the surface. So we build in this correction factor of 0.5. The surface features, such as the cold front, the warm front, are going to move at about half the speed of the winds at 500 millibars. So that's why we put the 0.50 in. Now the hours cancel out, and we have the correct units. 35 times 24. That would be roughly, let's see, 10 hours would be 350, 700 for 20 hours, about 840 miles times 0.5 would be about 420 miles per. In 24 hours, this would move about 420 miles to the northeast because it's following parallel to the isohypse pattern. So I'm going to take the low, and from the western portion of Iowa to the eastern portion of Iowa, that's roughly 300 miles. So I'm going to estimate this is about 300 miles from the low to here, and then a little bit more will move me to about 420. So the location of this low pressure system, 24 hours, will be further up into Canada. We're also going to move the cold front about 420 miles off to the east, northeast, and so that would be about right here. So in 24 hours, this cold front should be along the eastern seaboard. Now, what I need to do is move down to map 3 and put the 24-hour location for it. So I'm going to do that. I'm going to look back here, and the low pressure center is somewhere up here, and the cold front is along the eastern seaboard by tomorrow. So this map number 3 is the 24-hour location for the front. Now what about this front that is sitting up sorry for the dizziness, it's kind of hard to control the movement of this. But what about that front that is sitting up over the Dakotas? Well, we know it'll continue to move east, and the average wind speed here is about 45 miles per hour. So let me go ahead and do the calculations for the movement of this one. Okay, wind speed at 500 near the front is 45 miles per hour, times the number of hours forecasting into the future, which will be 24 hours. Hours cancel out, times 0.5. So 24